This is chapter 12, and chapter 10 we are done with it, with parametric curves and polar coordinates. Now we are in a new chapter, which will give us another dimension of thinking or sketching or whatever. So which is called vectors and geometry of the space. Vectors and geometry of the space. The first section is about three-dimensional coordinate system. Before this lecture, in Math 101, 102, you notice that most of the time we are talking about two-dimensional space, x and y, okay? X-axis and y-axis. We didn't specify or talked much about the three-dimensional space, except in some lessons, for example, in Math 102, when we talked about integration and revolving, the solid generated in 3 dimensions, but basically we are working with two-dimensional space. But now we're gonna our basis, everything will work in 3-dimensional coordinate system, okay, from now on. So 3D space, sometimes we call it XYZ space, sometimes we call it 3 minus space, which is 3-dimensional space. Sometimes we put R to the power 3. All of these refer to the same thing, which is 3-dimensional space or 3D space. The 3-dimensional coordinate system consists of 3 coordinate axes: the x-axis, the y-axis, and then we have the new axis, which is called z-axis. I believe it's not your first time to see this, but just to remind you, this is the x-axis. This is how we sketch it. This is x, this is y, this is z. X and y are perpendicular, and also z is perpendicular to the plane of x and y. هذه عمودي. This is perpendicular, perpendicular. Everywhere is perpendicular. Okay. So these are the coordinate system. Together will form what we call the 3-dimensional coordinate system. These axes determine 3 coordinate planes, which is called xy plane, xz plane, yz plane. Now you can imagine them like this. So this is the xy plane is the floor, okay, the floor, xy plane, which is all the points where it takes the coordinate x and y and z is equal 0, okay, so all of these down. This is the yz plane, the plane that formed by these 2 axes, y and z. And this is the xz plane, where the plane consists of the 2 axes x and z. طبعا the plane يا شباب is not up to here, it's infinite. It's going this and behind and up and down. Okay, the same thing for the floor. It covers all the way, infinite. Okay, infinite way. You can imagine such a thing in your house, in your room. Just look at the corner. Just stand in front of the corner. Imagine that corner down in the bottom. This is your origin. The 0 or O, and in your left, or the left one, as you see, in your left, the line down here, you can think of it as x-axis, and the other line here in the right, you think of it as a y-axis, and along this corner up to the roof, this is the z-axis. Okay, so this is the floor. This is the xy plane, but not only this floor, even behind these walls and everything down is the xy plane. This wall, you can think of it as xz plane, but think of it as infinite, all the way like this, and the same thing for the right wall, which is the yz plane. Okay. Now, if you have a point on these 3-dimensional space and you want to locate that, you want to give a location of that point will be represented by an ordered triple ABC. Now you remember in the 2-dimensional space, any point represented by 2 numbers, a pair, x and y, a, b, whatever. Okay, and we know how to find this point or locate it in 2 dimensions. In 3-dimensional space, we need 3 points. Okay, PC. A is the x coordinate of the point P. P is the y coordinate of P, and C is the z coordinate of P. And this is how we locate. If someone gives us the coordinates of a certain point in 3-dimensional space, what I will do, A, that means I go to the x-axis. For example, if A is positive, I will go A units. And then P is the y coordinate. Then I go either right or left from x-axis. If y is positive, I go right. If y is negative, I go left like this. Okay. And then the C, which is the z coordinate, I go up or down. Okay, depending on how the absolute value of C. So I go up if C is positive, C units, or I go down. Okay, so in this way you can locate any point in the 3-dimensional space using these triple here. Okay. Okay, Shabab, I want to ask you, Shabab, have you seen this before? in the secondary school, high school?
Yes.
Yes, okay, so you've seen this before, yeah. It didn't change from the time when I studied. Or physics. Oh yeah, in physics course also, you probably saw this. Actually, the next section also, you've seen most of it in the physics course. But anyway, so these are the three-dimensional space. Okay, so these are the same points. Now notice the following, ya shabab. A, the number A, you can think of it as the distance of the point B to the YZ plane. Okay, you can think A is the distance from the point B to the YZ plane. Okay شباب, you can think of it this way. يعني المسافة بين البوينت وهذا البلين اليسار, this is the A. And you think of B as the distance of the point B to the XZ plane, and C is the distance point B to the XY plane. خلينا ناخذ آخر واحدة يا شباب, the XY plane, okay, which is this one. So you see this point, XY plane is down, the floor. You want to know the distance from the point to the floor. What you will do, you will measure this line exactly as you see in my cursor, this line here. Okay. Now, how to measure this line? What is the length of this segment of line, which is C, right? Which is C. So this is the distance from this one. If you want to know, wallahi, the distance from the point to the XZ plane, that will be the point P. Why? Because if you have a point in the XZ plane, this means Y is equal 0. The distance, which is the length of this one, you see A, C, C. Only you moved P units. So the distance is P. And so on for the YZ plane. Okay? So notice that, shabab, any point on the floor, which is the XY plane, the Z coordinate is 0. Automatically. Okay? Z is 0. Any point on, for example, XZ plane on this left wall, the Y is 0 automatically. Okay, any point in this left wall, Y is 0. Any point in the right wall, X is 0. Okay, so you have these, and you know any point, you can form a rectangle, or a rectangular shape. So still we call it the rectangular coordinates or Cartesian coordinates. Still we call it the same way here. Okay. طيب, and later you're going to see how to do the polar in 3 dimension, and we have a new coordinate system. We're going to study it by the end of this course. طيب. Now the coordinate planes, the XY plane, the XZ plane, YZ plane, divide the space into 8 parts, not right parts, 8 parts. Okay. So let me, since we are talking about this, parts here. Okay. So divide into 8 parts called octants, and this is how we visualize the octants like this. Okay. This is the x-axis, this is the z-axis, this is the y-axis. تخيل إنه قسم لك البلين بهذا الشكل 8 مكعبات 8, but we call them octants. We don't call them squares or cubes, because we are thinking about them as infinite dimension يا شباب. We think of it as infinite dimension, but just for our limitation in this graph, we have boxes like this. Okay. The first octant is the octant consistent of all the points x, y, and z, in which x is greater than 0, y is greater than 0, z is greater than 0. If you notice, this is the red one, shabab, this is the first octant. Okay. Or if you are in the room, where you are standing here, this is your first octant. The first octant, shabab, which is x is positive, y is positive, z is positive. طبعا, where are the others? The second, the third, the fourth. يعني, some people, they do it this way: 1, 2, 3, 4, and then 5, 6, 7, 8. But in our, it doesn't matter really. Yani, when you go using these dimensions, it doesn't matter. No one will tell you, okay, go to the third octant, go to the fifth octant. It doesn't really matter that much. Yani, okay, what is important? The first octant. The first octant is all the x and y and z are positive, which you are, if you are in the room looking at the corner, the octant you are standing in is the first octant. Okay. The XY plane, sometimes we describe it in this way, as a set. We say all the points, the set of all the points, such that x is the real number, y is the real number, but z is equal to 0. Or simply, we put the equation z equal to 0. Okay, so if you want to represent the XY plane in a simple way, you can say, well, z equals 0. Okay, like in the two-dimensional space, x equals 0 means y-axis, y equals 0 means x-axis. Okay, the same thing. XY plane, we just simply say z equals 0. The same thing for the xz plane, you just say y equals 0. Also for yz plane, you just simply say x equal 0. Okay. طيب any question here يا شباب؟ Okay, so far so good. طيب, let's talk about the surfaces here. The definition of, maybe you've heard this word, okay? So in two-dimensional analytic geometry or in two-dimensional space, if you have equation of x, y, the graph of the equation, we call it curve. The graph of the equation, we call it curve, okay? In three-dimensional space, if you have equation containing x and y and z as variables, the graph of that equation, we call it surface. We call it surface. Okay, Shabab, please, there is an assignment or a quiz. Please go do it now. There is a attendance quiz going on. Please go and do it now. طيب. So we have this. Now, yes? Yes, Muhammad Hashim?
Yes. هاي تقدر هذا الميكروفون بالغلط.
Okay, good. طيب. Now, this is the example. Describe the set of points x, y, and z in a space whose coordinates satisfies the following condition. He said, give me all the points where z is equal 1. Where z is equal 1, ya shabab. Okay? So, okay, let me try. Where is it? Yeah. Shabab, what do you think? Good, huh? No, alhamdulillah. So now. So yeah, let me just put it a little bit down so you keep an idea what's going on. Yeah, z equal 1. Okay, z equal 1. So this is how we do. So you can say this is x-axis, and you draw a perpendicular line. So call it y-axis, and this will be the z-axis. So x on the left, shabab, and then y, and then z. And try to make it right angle as you can. طيب shabab. He said all the points where z is equal 1. Z equal 1, huh? What do you think, Shabab? Yani all x and y and 1 and 1. So yani it can be anything, but keep z equal 1. So where are we, Shabab? What do you think, Shabab? Where are these points? Yani how I can visualize them? Anyone? Yes, I don't know. Raise your hand. Raise your hand, Gabriel Mujahid. Okay. Okay, Walid. Yes, Walid. Walid Abdul Qawi. Walid, we cannot hear you, Walid. Okay. I will take. Yeah, تفضل Walid. Yes.
It's like a 2D plane, but lifted up to point 1.
Yeah, like a plane. So any point will be in this plane. So we can do it this way. Okay. All the plane passing through 1. It's like the floor. Yeah, think of it as a floor, but in the first floor here. Okay. All the plane, but shifted 1 unit up. Yeah, it is the same. You can think of it as XY plane, but shifted 1 unit up like this. So you have all the plane like this. Okay. Thank you very much, Walid. And what about if I change it into -1, ya shabab? What will happen? It will be the same, the plane, but below, below, down. So you remember, it is also, there is a negative part here. So it will be 1 plane down, 1 unit down. Okay. So this is it. You can write it as I said. All the points x and y and z, such that x is a real number, y is a real number, but z is equal 1. And you can sketch it this way. the plane on 1, and this is the XY, Z, a plane parallel to the XY plane that passes through the point 0, 0, 1. This is the description, how we write it for this one. And you see, notice that it passes the point 0, 0, 1. 0, 0, 1 يعني ايش؟ خلاص هذا البوينت اللي على which is the one on the Z axis here. Okay. طيب. We have other questions. Describe the set of points x, y, and z in a space whose coordinates satisfies the following condition. Okay. So let me put it down. Yeah, and we have it here. خلاص, we are done with this one. Let's take another one. And let's graph again the coordinate system. So let's say x, and let's say y. This is x and y, and this is z. Okay. Actually, I should say a little bit y like this. But anyway, remember there is a negative part and a negative part down here. Okay. Type. So here you have 1, 2, 3. You divide units like as you do on any axis, something like that. Okay. Type. He said all the points such that x is equal to y is equal 3. Fixed. What about z? He didn't give me anything z, so that means z is free. Z is free. So let's locate these 2 points. Let's try what we have. So we have 1, 2, x equal to 1, 2, and then 1, 2, 3. So we have 1, 2, 3. So this is here. We are here in this point, which is x equal to y equal 3. So where should I go? How many units I go up? How many units I go down?
Infinite.
It's 3.
Every point. Yeah. So it will be every point up and every point down. So it will be يا شباب what? It will be a line. Okay, a line.
But what if he say z is 5?
Yeah, if z equal 5, that means you are talking about a point. Okay, a single point. But if you didn't specify, yeah, if z equal 5, then I go 1, 2, 3, 4. يعني you have to follow what units you have. 1, 2, 3, 4, 5. خلاص and stop. خلاص.
Okay.
Okay, but if he didn't specify z, that means he is talking about all the points. But keep in mind, this line is parallel to the Faisal, to the. I know you have a question, but I just want to counter you. So all the points, the line parallel to the z-axis, Shabab. Okay. طيب, yes, Faisal.
Doctor, when we talk about 2 points, that means a line.
These are not
yes,
points.
We have 2
these
points.
No, not 2 points.
I mean, two coordinates.
Yeah, he gave me 2 coordinates. But remember, we are talking about 3 dimensions, so I need to know what will happen to the z. He didn't specify z, so I put z. يعني it means that this is free. Okay. This is free. So mean free يعني ايش? It can be anything, up to down. So you are covering all the points. Actually, I draw the line really slant, but I mean really like this, yeah, really like this, yeah. Okay. So all the points up and down like this. Okay. واضح؟ طيب.
When we talk about one coordinate, it's a plane.
Yeah, if you talk about one coordinate, it's a plane, like this question. Like this question.
Yes, okay.
Yeah. If z equal 1, plane. Let's go back to this question. So what about if someone told me y equal 2? كده y equal 2. ايش يعني هذا y equal 2 يا شباب؟
X and Z is free.
Z free, and what will be? It will be a plane like this, يعني, okay? For example, like this. Passing through this point, يعني, okay? Something like this, يعني, okay? We have plane cutting y axis here, okay? طيب. The similarity for x, yeah. But keep in mind, not always positive. It could be negative, it could be negative, it could be anything. طيب. Yeah, so we have this. Now, the second part is that describe the points in the space whose coordinates satisfies the following condition: y greater than equals 1. Y greater than equals 1. Okay. So also let's do it again. Y greater than equals. Sorry, I said 1. I mean 3 here. Okay. So again, this is x-axis. This is y-axis, and this is the z-axis. Okay, so let's say 1, 2, 3. طيب بعدين يا شباب He said y equal 3. So what should I do? Okay. يعني هو كل البوينتس بس انه هذا ايش؟ y is greater than or equal 3. Okay. So what is x3z? خلينا نبدأ من البوردر. What is x3z? Meaning that what is y equal 3? A plane, right? A plane, يعني like this, for example. Okay. Actually, it is even negative part. Okay. طيب. هذا y equal 3. هذا one plane. Okay. What about if I said y equal 4? It will be another plane, right? Like this. What about if y equal 5? Another plane. Y equal 6, y equal 7, y equal 8. So what does it mean, ya shabab? We have what? We have the whole thing. The whole thing. Okay? The whole thing from y equal 3. You cut all this half, we call it half space. We call this half space. Okay? Yani you're taking half of the space. But yani, some of you say, why half? Why if it's 0, we call it half. Because we say everything is infinite. So this is infinite way. So we call it half a space here. يعني من y3 وانت رايح كده شباب, this is half a space here. Okay? So this is when someone tells you y greater than or equal 3. So it's not only one plane, it is infinite planes together. So we think of it as a half a space, like this. Okay? Right. So this is a line parallel to the, as we said, z-axis passes through the point 2, 3, and 0. And this is the other one is the half a space consisting of all the points and to the right of the plane y equals 3. Y equals 3. Okay. Right. And the next one, Shabab, is find or describe the set of points that satisfies the following condition: y equal x. Y equal x, Shabab. Okay. And we will do the other one down. Okay. So this is here. Keep in mind, Shabab, if someone told us describe the points y equal x, kid, huh? Y equal x. We wrote it like this. We have to specify the dimension space. Yani you're gonna reply, I am in 2-dimensional space or in 3-dimensional space. Because in 2-dimensional space, this is what? ايش يمثل يا شباب 2-dimensional space?
line.
Line. Okay, the famous line. But in 3-dimensional space is something different. So someone should, yani, we have to know what is the context we are working with. If we are working in 3-dimensional space, this means something else. Okay. Okay, so now, so let's draw the x-axis, let's draw the y-axis, and let's draw the z-axis. y equal x يا شباب, يعني y equal x هذه أعرفها صح؟ يعني what will be يا شباب? It will be this line صح? If you imagine this is x and y, and y equal x, you will graph it this way, right? يعني it is a line in the xy plane here, right? طيب, what do you think happened in the plane or in the 3-dimensional space? It will be
راكب فوق ونازل تحت.
yeah, so it will be a plane like this, يعني, okay, a plane like this. All the plane, okay, all the plane cutting the z-axis here, شباب, okay, all the plane this way here, okay. But I can use actually this software. Actually, if you remember, I recommended you to do it. Okay. Okay, it seems it's not working, but I did not save. Okay, it's fine. We can work it out. طيب. It has many things يا شباب. يعني you can take the 3D calculator. So if you said y equal x, so this is y equal x يا شباب. Keep in mind, look at the arrows. In the red one, this is the x-axis. This is the y-axis. This is the z-axis. And look at the plane. How it goes like this. Okay. How it goes like this. Okay, so this is a plane y equal x. Yes.
دكتور
Yes.
تقدر ترسم y greater than 3 لاني صراحه ما فهمت كيف جاي الرسم.
طيب y greater than or equal 3. Okay. Actually, he will not sketch. He will sketch like this down. It's not really the y greater than or equal 3. Okay. It's not really y greater than or equal 3. Okay. But no, I don't think this will do. يعني ما أعتقد البرنامج راح يحسبه. Okay. Because he did only grade it down. But I mean here is 3-dimensional space. Yeah. Okay. Unless if I said x greater than or equal مثلا 0, z greater than or equal 0. No, it will not grade it here. It won't grade it here. Okay.
بس
طيب.
الشكل بيكون طالع على الزد والفوق
yeah, it's infinite up and down, but it goes this in the left يعني. Okay. It goes like in the positive direction. Okay. طيب. Yes. The last one, Shabab, describe the points in the space whose coordinates satisfies the following condition. Z is between -1 and 5. Z is in -1 and 5, Shabab. So what do you think? Where? Yeah, here. Okay. What do you think, Shabab? So let me bring it on the left. Another paper. Okay. So what do you think, Shabab, will happen here? X1. Z, and there is an extension down. Okay, so we are talking about a -1, so 1 unit down, 1 unit down, and one, let's say somewhere here, the 5. Okay, so he said all the points between these two planes. So you can have a plane like this, and you have a plane down here like that. Okay, so I mean we have to do it in dots. Okay, but what else, Shabab?
the area between the two planes.
All the points between these two. Okay, it's not cube actually. It's really going all the way, Shabab. All the way here, everything. Yani, but we are drawing just a plate like this, indicating the whole thing, infinite, but only between these two. Only between these two. Yani any point below it, below -1, is not included. Any point above 5, it's not included in our region or our plane. So it consists all the points between the two planes. Z equal -1 and Z equal 5. Okay. Right. So this is the first one. We say the plane perpendicular to the XYZ, passing the point this. And this is all the points on or between the horizontal plane Z equal -1 and Z equal 5. Okay. So at least, يعني, I hope at this point we can visualize the regions. If someone give us regions, a few planes, we can يعني, describe them in the XYZ plane or space. Okay. Now there is something called cylinders. You know the cylinders before, but we can describe them in this way. For example, describe the set of points x and y, z in a space whose coordinate system satisfies the following condition: x squared plus y squared equals 4. Okay, equals 4. So we can do it this way. Okay. طبعا يا شباب, if someone told you just out of, from the street, he told you graph x squared plus y squared equal 4. Then you need to know whether I'm working in 2-dimensional space or in 3-dimensional space. In 2-dimensional space, this represents a circle with radius 2. But in 3-dimensional space, it will represent what we call the cylinder, the same cylinder as you learned before. So this is x, this is y, and this is z. Okay. So x squared plus y squared equals 4. Now he didn't specify z. Yani here z is free. Is free. Okay. So no, 4 means 2. So let's grab a circle. Let's say يعني هذه like this. Okay. So let's say this is like this, and okay, this is a circle of radius 2. Okay, but it's not only in the xy plane. It's all the way up. Okay. And all the way down all the way down. All the way down. So but where do you think يا شباب the inner اللي جوا يا شباب is included or only the surface, only the lateral surface of it?
Only the surface.
Only the surface.
Only the surface. Okay, very good. Fahad, I'm sure you want to say the same. So only the surface, not the inside is not included. So just all or the inside is empty. Okay, you can say empty, not included or whatever. يعني empty. طيب يا شباب, if I want to I want to include the inside. What should I change in this equation? يعني I want cylinder of radius 2, but I want the inner points to be included. So what should I say? Anyone? Raise your hand. Yes, عبد الرحمن.
ممكن أقول من 0 إلى 4.
No, everything infinite, يعني up and down. Yes.
ممكن اعطي له زد قيمه.
No, I'm talking about infinite, up and down, okay? But I want the inner points included. Ibrahim, yes, Ibrahim.
Bigger or equal to 4?
Less than or
smaller or equal to 4.
Or equal to 4. Very good. So this is how we're gonna include the inner points, okay? This is how we include an infinite surface here, okay? يا شباب. طيب. بالنسبة لي يعني regarding to the some answers I received, يعني if someone said x squared plus y squared equals or less than or equals 4, but he said z is between 1 and 3. Okay, if someone gave me something like this, so he means a cylinder with inner points, but only a portion here, only a portion of the cylinder. So we have a finite cylinder, a finite cylinder. But writing this way, Shabab, you are talking about infinite. Yani there is no top, no bottom. Goes all the way infinity, goes down infinitely like this. But only the boundary you have is in radius 2. Okay, radius 2 up and down. Yes, Faisal.
Doctor, if we said more than or equal to 4.
Yeah, so more than equal to 4, that means you are talking about cylinder, the base. You have some base, which is on the z equal 4, and infinite top. Okay? Okay. طيب يا شباب, what about someone said like this? Z equals 1. What do you think? He told me x squared plus y squared equal 4 and z equal 1.
Circle with radius 2.
The circle of radius 2 بس. Anyone? Fahad? Yes, Fahad?
At z equals 1.
يعني I have to go up to 1 floor.
Yes.
It will be this circle. This is what you meant, Fahad. Exactly. Okay? So he's talking about circle. This is circle. If he gave me everything like this in a specific way, z equals certain number and the equation of a circle, then this is a circle, circle of radius 2 center. What will be the center يا شباب؟ مين يعطيني السنتر؟ What is the x coordinate؟ هذا البوينت مثلا. What is the center؟
0, 0, 1.
0, 0, 1. Very good. Center 0, 0, 1. Okay. Or the center will be on the z axis. Okay. So this is the cylinder. This is the cylinder. But this is infinite. This is finite. Okay. And this one is this is a cylinder with inner. This is the cylinder. The inner is empty. So only the surface of the cylinder. This infinite. This infinite. Okay. Right. So these are the cylinders. So it's an infinite cylinder of they're off. So okay. Can I change it? Okay. Off radius 2. Okay. بتغير. حلو. Okay, good. So off radius 2. Okay, that's it. Now, the second part of this section is about distance and spheres. Distance and spheres. Can we find the distance between 2 points in a 3-dimensional space, like what we can do in 2-dimensional space? The answer is yes. And this is the formula for the distance in 3-dimensional space. So if you have 2 points, x1, y1, z1, and another point p2, which is x2, y2, z2, you want to find the distance between these 2 points. It will be like as you do in the 2-dimensional space, but you add this term. So it will be square root the difference of x-axis squared plus the difference in y-axis, y-coordinates squared plus the difference in z-coordinates squared. Okay, so it's very similar to the 2-dimensional space, and I think you've taken this before. I think you've taken this before. Okay, it's not your first time. Okay, now this is just a quick example. It's a solution right away because it's really straightforward. Find the distance between these 2 points. So notice the notation, يا شباب, يعني we put like absolute value and we put the 2 points PQ. PQ. So this is absolute value PQ, which is equal to you calculate it. Just substitute the formula, and for example here the distance is 3. Okay. طيب. Now let's talk about spheres. Let's talk about spheres. Now you have a sphere. Okay, you can think of it as a pole. Okay, a pole in 3-dimensional space. Now this sphere, how are we going to define it? We're going to define the set of all points who have the same distance from a certain point. Okay, which is, we call it center. So the sphere, we can define it as the set of all points who have the same distance from a certain point. That certain point we call it center, and this distance we call it radius, which is r. So assume the center is call it the point C, which has the coordinates h, k, l, and this is the point, any point on the surface of the sphere, which is p, x, y, and z. So equation of the sphere is given this way, which is x minus h squared plus y minus k squared plus z minus l squared equal r squared. Okay, it's very similar to the equation of the sphere in 2-dimensional space, but here in 3-dimensional space we're gonna have it this way. In particular, if the center is origin, then h is 0, k is 0, l is 0, so automatically you will get this. Automatically you will get this. Okay. طبعا يا شباب يعني whenever you have a distance, automatically you will have a sphere. يعني نقدر نعرف السفير على طول. We can define the sphere right away. So let's take this example. He said, show that this equation, it looks complicated to you, but you can show that this is equation of a sphere and find its radius and center. So let me just copy this equation here quickly. So this is x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 equals to 0. Okay. Now, now how to show that it is a sphere? It's the same way as you did in 2-dimensional space. So Faisal, what should we do?
We complete the square for all variables.
Mumtaz, complete the square. Did you notice in the previous quiz that we had a lot of completing squares? In the questions, the previous quiz?
Yes.
Even one of the questions I put just a hint, complete the square. Okay, so we have completing square a lot in the previous quiz, and here we need it also. So we know that we have x squared plus 4x plus, we add something, and we gather the y's together. So we have y squared minus 6y plus will be something, and then plus z squared plus 2z plus it will be equal something equals the 6 will be negative 6 here. Okay, now what should we add here for the x, shabab?
4.
4, and here we add both sides. Here, shabab?
9.
9. And here?
1.
1. Okay, 1. So this is what we have. Now here, shabab, it will be x plus 2 all square plus y minus 3 all square plus z plus 1 all square equal to. Now you have to gather all of these, so we have 3, 7, 8. 8. So we have this way. Right? Now, so this is this is an equation of sphere with or center at, okay, who gonna give me the center يا شباب? Anyone raise your hand? عبد الله درويش، ما سمعتك اليوم عبد الله. Yes, give me the center يا عبد الله. عبد الله, are you with us?
Yes, doctor. -2 and 3 and -1.
minus. Very good. طيب. Radius عبد الله فيصل. Yes. عبد الله فيصل. What is the radius?
2 square of 2.
Yeah, which is the square root of 8, which is 2 square root of. Very good. Okay. طيب. So the key idea to discover whether I'm dealing with a sphere or not is the complete square. Either you have exactly the same formula or you do the completing square. Yes, Abdul Aziz.
No, just I want to answer.
You want to answer? Okay, good. Fine. Good. So I think these things are clear, like the spheres and so on. So we have this. طيب يا شباب. Now let's go to the last question. The last question of this section, and we have it this way. Find the equation of the sphere with center 1, -2, 2, and radius 3. Describe the intersection with xy plane, the plane z equal 5 and the plane y equals 2. Okay, so let me just shrink it a little bit and increase it this way. Okay, and you can see it clearly. طيب يا شباب. This question contains many parts, so let's first find the equation of the sphere with center. Okay, equation of sphere with center 1, -2, 2 and radius ايش 3. radius 3. يلا ايش هو الايكويشن يا شباب؟ raise your hand if you know how to do it. Like a circle. Rakan, I didn't hear you, Rakan. Yeah.
X minus 1 squared.
Minus 1 square plus
Y plus 2 squared.
plus 2 square. Very good. Plus
Z minus 2
square equals. It's 3, so it means
9.
9. Okay, I didn't hear you. Good. 9. Good. طيب. So we have this equation of sphere. But very good. Now let's go to the next part. He said describe the intersection points with the xy plane. Okay. So here I will say intersection points with xy plane. How to find it, Shabab? In general, Shabab, if you have two curves, let's say in two-dimensional space, you want to find two curves in two-dimensional space and you want to find the intersection points, what you will do?
You equal them.
Equate them. Very good. Like now we are in three-dimensional space. I have equation of a sphere and I have xy plane. So there is a similar idea actually. We equate them, but how to do that? What is the equation of xy plane? Do you remember? Raise your hand if you remember. What is the equation of xy plane? Mujahid.
Z equals 0.
Yeah, z equals 0. هذا الايكويشن حق البلين هذا xy plane. So I have z equals 0. I have this equation. So what I can do? Substitute z equals 0 in the equation. خلينا نقول هذه equation star يعني عشان we refer to this one. So what will happen? You will have this. You will have x minus 1 square, keep it as it is, y plus 2 square plus. So when I substitute 0 here becomes 4 equals 9, right? Now let's make it clear. Equals what يا شباب؟
5.
5 equals 5. Okay, equals 5. طيب وkeep in mind يا شباب هذه and z equals 0 and z equals 0. اوكي هذا يمثل ايش يا شباب؟ لانه ترى هي عند الاكس واي بلين ها. What do you think? Yes, Bassam.
It is a circle with the radius square root of 5.
Circle, center,
1 and minus 2.
1 and minus 2 and ترى نحن في 3 dimension.
0.
0 وراديوس
Square root of 5.
square root of 5. Okay, square root of 5. Very good. Okay, so when the sphere intersect with the xy plane, we will get a circle here. Okay. Actually, we can, يعني, if you want to verify, we can have it here. This program, when I leave it away, it gets mad on me. So let's. Alhamdulillah, closed. Good. Otherwise, I will deal with it a harsh way to close it. طيب. Yeah, I see your hand raising, but I want to go this way here. طيب. So remember, يا شباب, the equation is x minus 1 square plus y plus 2 square and then plus z minus 2 square. I know I wrote x capital, but it's okay. Equals 9. Okay. So actually x here. Yeah. So this is the sphere. Okay. So this is the sphere as you see here. Okay. Right. Now, when I put z equals 0, which is the xy plane. Okay. Now what will happen here, Shabab? If you look at it, what are the intersection points here, Shabab? It will be the circle, right, Shabab? It will be the circle inside here, okay, which is really the boundary here, this way here, okay. Don't know if I can find the intersection of two. Yeah, the intersection of two surfaces. Yeah. The intersection, yeah. So yeah, he actually let's forget about it. Yeah, you see the dots here. This is the circle, really the circle here. Okay, the dots, all these dots are the circles here. So if I close this and this, you will see that this is really the circle inside here, Shabab. Okay, yeah, you see. This is the circle we are talking about here, okay? And the center we have it here, which is 1, negative 2 and 0, which is he found it here, 1, negative 2 and 0, and the radius is square root of 5 here, okay? Right, good. Yes, Abdul Aziz, what is your question?
Why did we choose 0? Why we didn't choose 1?
XY plane. What is the equation of XY plane?
X square y square.
No, XY plane. XY plane. And when I say find the equation of XY plane, what is it? Okay. طيب خلينا أقرب لك المفهوم شوية. Something you know. Okay. Something you know. يعني it's similar idea. In 2D, two-dimensional space.
Okay.
What is the y-axis? How you represent y-axis as an equation? What are you gonna say?
Y equals something.
No, not y equals something.
X equals 0. Sorry.
X equals 0, صح? X-axis, you're gonna represent it y equals 0. Here the same situation. Okay? Here the same situation. When you say xy plane, you mean z equals 0. Okay? The other one, and yz plane, x equals 0. Then what we left, yz plane, x equals 0. Okay? You take the other variable which is not here, make it equal to 0. يعني I don't want you just to memorize it this way, but it means that all the points where the Z is 0. So XY plane is like when you're standing in the room, it's what your feet, all the plane on the floor, okay? All the floor.
Okay. I get it.
Okay. Good, very much. طيب, now let's think about part 2. Let's do part 2. Okay? Let's do part 2. Now this is the equation of the sphere still, and I want to find the intersection points between this sphere and, as you see in 2, the plane Z equal 5. So we will do the same thing. Okay? Here we'll say intersection points with Z equals 5. Okay? So I will substitute. So we have x minus 1 square plus y plus 2 square plus here you have 5 minus 2 square equals 9. So you have x minus 1 square plus y plus 2 square plus كم هنا يطلع يا شباب؟ 9. Okay, so let's take this away. This will be 9 equals 9. So it means that x minus 1 square plus y plus 2 square equals, طبعا 9 will cancel each other, right? So we'll get 0. طيب, then what?
There is no intersection?
No, actually. Like, let's agree on something. Let's agree on something. And I will
Will be a point.
If you have
Single point.
yes, this is what to say. A square plus B square equal to 0. إيش معناته يا شباب? What I can conclude in general, إنه A is 0 and B 0. In general, you have to include this way. يعني there is no other solution. يعني ما في أي numbers تعوضهم هنا يعطيك the square, the plus of the square is 0. ما في غير إنه لازم يكون A 0 و B 0 كمان. ها? So it means that they have the same situation. It means that x minus 1 is equal to 0 and y plus 2 is equal to 0. So it means that x equal negative 1 and y equal negative 2. ولا تنسوا يا شباب.
هو وين يا دكتور؟
أي 1 yeah 1 sorry 1 negative 2 and don't forget I am in this plane which is z equals 5. So the conclusion يا شباب, it is, what do you think?
A point.
Line
Point.
It is a point, or the point is the point 1 negative 2 and 5. 1 negative 2 and 5. Are you interested to see this يا شباب in the program? I hope إن شاء الله. Yeah, good. Okay, so we're still here. طيب, so we have this sphere. Let me just zoom out. Okay, let's have this sphere, and let's say z equal 5. Do you see the point? Do you see it? This is the point here. Okay, this is the point here. Okay, so this is the intersection between the sphere and the point. Only this point. I think if I find it this way, this and this. Okay, this and this. Yeah, so I got the point now. So if I remove these, I found the point. This is the point. This is the point here. Okay. Even he found the coordinate points here. 1, negative 2, and 5, as we did it by calculation. حتى هو حسبها هنا. Okay. So yeah. So this is what we have here. Okay. طيب. So let's keep the sphere. Let's turn off everything. I am actually this way. Okay, turn everything off. So still I am in this sphere here. Okay. طيب. Now let's take the last one يا شباب. Remember the equation is x minus 1 square plus y plus 2 square plus z minus 2 square equals 9. Okay, let me just check. Yeah, this is what we found it. طيب. Now we need the intersection with y equals 2. We will do the same thing يا شباب. We substitute. So here you will have كم عندنا يا شباب هنا محل هذا.
16.
which is equal 16. We can replace it by 16. So you have x minus 1 square plus z minus 2 square equals. Now keep in mind, Shabab, when I move 16, let me just erase everything. When I move 16 to other side will be negative 16, right? Negative 16 and 9, so I have negative.
Negative 7.
Negative 7, okay? Like, now look at this equation. The left-hand side you have positive, the right-hand side is negative, and this is completely positive. No way you will find a point that will make positive and this negative, okay? So this equation does not have a solution. واضح يا شباب؟ مستحيل يا شباب. No way you will find 2 points that will give you negative. Why? Because you have a square here. Okay. So the conclusion, what will be?
There is no intersection point.
There is no intersection points. Okay.
دكتور
طيب. يس عبد الرحمن.
يعني معناته ان النقطة هذه هي ما هي موجودة داخل السفير هذا يعني.
No, it means that the sphere and the plane do not intersect. كل واحد في حاله. Okay. We can visualize it here. So this is the sphere اللي احنا قلنا عنه. خلينا نحط y equals 2. هذا this wall is y equals 2. خلينا كده نطالع من الجنب. شايف ما في intersection point between them. They do not intersect. Okay, which really confirms our calculations here. Okay, so this is a sphere, and this is y equals 2, not there. I don't know why it disappeared here, but I did it this way. I think by accident I hid the y coordinate, but this is the sphere and this is the wall. Yeah, you can check it there. Okay. طيب يا شباب. This is it for today's lecture. This is what I have in mind. Please go and solve the exercises in this section. There is one exercise actually. I liked it, and I don't know if you go to solve it. I don't know whether you're able to do it or not. But I feel like I was really hesitating whether to put it on the slide or not. Okay. Let me write the question. It says this. Determine sorry شباب. في سؤال بس خلينا نناقشه كده بدنا في آخر 5 دقائق. Determine whether the points lie on a straight line, and he gave you points. For example, A 2 4 2, B 3 7 negative 2, C 1 3 3. I'm copying the same exercise from the textbook, from the textbook. I have older version actually, but I don't know if it's the same in the newer version or not. Like, determine whether the points lie on a straight line. Okay. طيب يا شباب، عشان نجاوب على هذا السؤال لازم نفهم كيف نعرف يا شباب a point lie on a straight line.
Same slope.
ترى ما درسنا السلوب لسه ها. x y. We have a point 1 2 3. Let's talk about two-dimensional space. Two-dimensional space. ونفس الفكرة تنطبق على three-dimensional space. How to tell these 3 points lie on a line? طبعا don't tell me I sketch them and try mimic it by looking at it. No. We have to do some calculations here. Okay. So when I say a point in two-dimensional space, they lie on a straight line. كيف نعرف يا شباب؟ By calculations يعني. What we know about the points, we know how to locate them, but this is not big deal. We know how to find. Mujahid, what should we do?
I think we should probably find out the slope for 2 points and then the 2 other points and see.
By the way, we didn't know how to find the slope at this stage.
Yes.
Later we will learn how to do the slope in 3-dimensional. In 2-dimensional we know how to do it. Find the equation and try to figure out whether the point satisfies that equation or not. You are right. If we know how to find the equation of the lines. But now at this stage in 3-dimensional space, we don't know how to find equation, slope, all of these stuff. Okay, let's agree on this. So let's say I don't know. Later you will solve it in a different way actually. Okay, what should I do? Anyone has an idea without using slopes and this stuff? Like, let's say this is point A, this is point B, this is the point C. Look at the distance from A to C, and look at the distance between A to B and B to C. What do you notice, Shabab?
Identical.
Other distance A to C. Okay, sorry. وهذا distance AB وهذا distance BC. What do you notice, Shabab?
ان AB equal to half AC.
Plus. What? If they are in the straight line, but if they are not in the straight line, then yeah, it's not true. Okay. For example, if you have A, like
an assignment.
yeah, assignment. Yeah, there is an assignment, Shabab. Please go do it now. Thank you very much, Akhui. Okay. There is an assignment, Shabab, quiz assignment or attendance assignment. Please do it now. Okay, so if you have 3 points that are not in the straight line, then you know that the distance here plus here is not giving this way here, right? It's not giving this way. Okay, so if they are in the straight line, that means the smaller distances, when you add them up, they should give you the bigger one, Okay, so this is one way to find straight lines. So what I will do, Shabab, calculate. Find the distances. Okay, the distance AB is equal the square root. You'll take the difference 2 minus 3 square plus 4 minus 7 square plus 2 طبعا minus will be plus 2 square. طبعا تحسب you will get 1, you will get 9, and you will get here 4, 16. If I 4, 16, or 3, which is 9, and here you get 1, 10, the square root of 26. The distance from P to C, which is equal to 4, because I take the difference and then square it. Okay, 7 minus 3, 4, which is 16, minus 2 minus 3, which is minus 5, which is 25. 25, sorry. So here we have 20, 45, and then the point AC, which is equal, you take the difference here, so you have 1 plus 4 minus 3, which is 1, 2 minus 3, which is 1, 1, so we have the square root of 3. Okay. طبعا you try to approximate these, what are they, and check. This is the biggest one, right? Square root of 45. Is it equal to the square root of 3 plus the square root of 26? I don't think so. This is not true. Okay. So what is the conclusion, Shabab?
They're not on the same.
They are not on the same line.
The same, yes. So these right here, just on the page. Right. So these points are not on a straight line. Okay. طبعا هذا الكويشن يا شباب it contains two examples or 2 parts. I took one of them and we found it not on a straight line. You try the other set of points, you will find it straight. I'm sure he must put one. They are on a straight line. Okay, so you have this. طيب يا شباب آخر سؤال قبل ما نقفل. If he gave you 3 points and he asked you, are these points vertices of a triangle, or will these points form a right triangle or not? right triangle. كيف أعرف إنه بيشكل لي right triangle؟
مجموع طول كل عمودين يكون أطول من الثالث.
اديني كلمة السر.
Pythagorean theorem.
Pythag يعني something like this, huh? Something like this. Okay, I forgot even the spelling. Huh? Pythagorean theorem. Okay. So measure the distances. Measure the distances. We did it here actually. Measure the distances. The square. So this square should be equal this square plus this square. Okay. But you notice that 45, 26 plus 3 is not equal 45. So these will not form also right triangle. Okay. This is also another example of you can do what you can do in the 3-dimensional